Hi there, and welcome to Weekends Web App. This is day 19, and the stream is where we're building a web app from start to finish. All on stream, absolutely nothing hidden. So, if you want to follow along at home, let me just bring up the project. If you want to follow along at home, you can pull down the repo from github.com/weareoffcider/weekendswebapp. And pull it down. Every bit of work we do, we push up on here every time. Now, if you want to follow on with today's code, we finished off on day 18 yesterday, so we are now on day 19. Bring up the scale size. So you want to check out day 19. Check out day 19 to get the code from that day. At any rate, we're going to pretty much pick up where we left off yesterday with regards to testing. So last time we did some work. We set up ourselves a server, and we set up ourselves a sort of a scaffold for doing our testing. And we changed from Jest, which is our original tester, and we changed over to Mocha. And the main reason for that is so that we could do our tests inside the browser. Because you remember that if we always do our tests within the command line, which is what we were sort of limited to with Jest, so we'd just run some command like yarn test, we'd get our tests and we'd run them, but we'd have no verification that they would actually work in Firefox, in Safari, all those sorts of things. Whereas if we can run the tests in the browser like this, then we've got this scope where we can be sure that the tests are going to work on our target platform, because most of this code is going to be running not in Node, but in the browser. So it only makes sense to test it within there, rather than there's all sorts of convoluted ways you can sort of try and make it work. And there's this project called JSDOM, which is all about that. But I mean, the problem with it is if you're doing that to try and manage your testing, you end up putting way too much effort into your testing framework, and we don't want to do that. We just want to run our tests in the platform where they're meant to run. Seems like something reasonable, right? Now, we got started with our number formatting, and we're going to just continue writing some test code and sort of fill in all the gaps as we go. And this will give us a good chance to sort of take stock of our code as we go as well. So I'm just going to push this into... We'll get rid of that. We'll push this into another page, and then we'll start with our code. So if we jump into our localized context, we may as well finish off the tests there. So we got some tests for our number formatting, and that's great. Let's get rid of that comment there. Wasn't meant to be there. And let's make ourselves a new scope for testing our datetime formatting. Alright, so date and time formatting, and we'll have a look at our actual code here so that we can sort of see what we're doing. Right, so let's see what we have here. We have our format date. We'll want to test abbreviation and full. Format date time naive, we'll want to do the same thing. And then finally, our format date time UTC, which comes with not only the formatting, but with the localization. And as I said, there are more things that we could do, like relative times, like 5 days ago, 5 days in the future, and that kind of thing. But for the moment, we don't want to have to think about that sort of stuff. And until we need it, we don't need to write it. So we'll just stay focused on the stuff that we've got in front of us, the problems that we have in front of us, rather. Okie dokie, so let's see. We'll start off with format date. And pull that off, format date. And now, if you'll remember, we always talked about our transport format being a string. So we're always going to be formatting strings. We are not going to be sending in any sort of like JavaScript data or anything like that. We want to always be handling with strings, staying in that transport format for as long as possible. So if we do something like this, now this is going to be wrong, but I'm just going to run it and verify the test that we get back. So May 5, 2018. That's the fair format for just EN, simply because that I believe that's the American format. So I might just actually double check that and see what it looks like when we do US there. Wait, let me reload. There we go. Yeah, so that looks like US, and if we were to go AU, we'd probably end up reordering that. So yeah, you can see there, 5 May 2018. That's fine. I'll just stick with EN for now, even though I'm Australian and it hurts my sensibilities. That'll do. We're happy with that answer. Okay, and the default for that is full. So let's see what it looks like in abbreviated form, and then just check that ourselves, see if it matches. 5/5/2018. Okay, we're cool with that. Lovely. All right, let's go on to date and time. So here, I mean, technically these would probably do something, but these would do something with these. They would just assume that, all right, well, we don't have any date time information, so we can't do it, and that's fine. That still works, and I guess that's kind of undefined behavior, but it's not really that bad. So I'm actually happy with that as the default behavior. So I might keep this one just as a sort of a verification of what we'd expect if something without a time was put in there. And that way, if that ever changes, we know that we've got an assumption in our code that's sort of broken. Now, if we carry on with this, now let's put a time in here, like something like 04:30:21. I don't think that will ever show up, but let's just see what happens. I don't think the seconds will ever show up, but that looks right. That looks like a nice little rounding. So I'm happy with that. I'm going to keep that one. And finally, we're going to see what that looks like in full. I only have abbreviation in full here, so that should be fine. So we just have the slightly longer version. And we're good to go. All right. So finally, let's put in some for our format date time with time zone handling. Now this one's a bit awkward, right? Because at the moment, we just assume the time zone. So what if we write the tests? Is it going to automatically be the same way for Australia, or are we going to have to set our time zone? And like honestly, this is a pretty common thing, right? Like what is the best way to handle this? So I'm going to have to defer to seeing what I can do for time zones in a sort of a global sense. And I'll just have to see whether, what's it called? Whether Luxon gives us some ability to sort of override it. Because if I can't set the locale, like the time zone of a particular thing, then we might be in a bit of trouble. So let's see what we can do with that regard. So we'll start with a UTZ and 21, and we'll put a Z on there. Because that should be format date and time. Hang on, I'll change this to format naive date and time, and we'll change this to format UTC date and time. So there we've got that time change right there. No good. So we've got that time zone change, and we need to be able to sort of set that to a fixed point. Otherwise, we're always going to end up with this being wrong in certain cases. So I'm just going to check in with date time with Luxon and see if there's some way to control this time zone in this particular case, because otherwise it's just going to throw off our tests. The alternative is we only test the formatting of UTC time, because that we could do safely. But I want to see if there's something we can do here that'll get around this issue. Alrighty. It's probably a time zone section. There we go. Specifying a zone. So can you set a local zone by default? Specify what time a zone is made on. Set zone. Changing zones. Alright, so that's immutable. Can we make it so that changing the default zone? Here we go. Okay, by default, Luxon creates date times in the system's local zone. However, you can override this behavior locally. And you can reset by setting it to local. Okay, so we can potentially isolate all of this by grabbing... so we'll import settings from Luxon. And it looks like we should be able to go settings.default zone name. And if we do something like Asia Tokyo, just going by the example that they've got here. So we can do this, and then we'll just reset it. Now, Asia Tokyo is actually pretty close to my one. So how about I do something different? How about we go Europe Zurich. And then we'll reset the default zone name back to local after we're done doing our tests. All right, let's run him. Okay, so we can see 6:30 a.m., which is, let's test our assumptions here. So that would be, let's see, that's 2 hours, 2 plus 2, which Zurich is plus 2. So that looks correct to me. So that'll be 05, 05, 6:30. Yeah, I'm happy with that. So that is the correct result for UTC. And notice we're not actually putting any post fixes on it, or we're not, like this is a local time formatted thing. So this should be fine. And maybe one day we'd put UTC on the end of these. Actually, I feel like that's maybe the better way to handle it. We could do something like this. But I don't think we're actually far enough on that. Yeah, maybe we should. Maybe we should. All right, it doesn't matter. We will do abbreviation. We're defaulting to full, so we can do abbreviation as well. So that should look like 5, 5, 6:30 a.m. 5, 5, 2018, 6:30 a.m. I've done all that with my... Let's jump down there. Just give you a little more room so you can see. So I've done there 5th of the 5th, 2018 as our thing. Let's refresh and it works just fine. That's good. Right, so we've got abbrev local and full local, which are actually identical to these. So we don't really need to test them. I mean, we may as well, just because they're another setting, they're another place for something to go wrong, and we may as well acknowledge that by making sure that they do actually work. Even though the code is identical. Yep, very good. And finally, we've got UTC. So abbrev UTC and full UTC. And those should both be at 4:30 a.m. To compensate for the change, you can see 4:30 a.m. right there. Are we good? We are good. Whoops. Yep, you can see everything we need to. All that code's running and all that code is running successfully. Great. So we've got our date time formatting and everything is just fine. All right, let's grab a test locale finally and have some pluralization in there and stuff like that. So what do we need? We need some count. is count item. Count items, and we'll do that with plural. And then what else do we do? Let's do standard string. Standard string. That will, yeah, that'll do for now. I don't need to do anything more complicated than that. So I feel what we'll carry on. I'm just going to reorder this because just match the ordering of the actual source file that it's testing. And we'll zoom on up here and describe the text. Describe the text formatting. Text translation, rather. Alright, we're doing exactly the same before steps as before. I mean, let's hoist this up, because until we're doing more than one locale test, it makes no sense for us to do it here. So let's just do that up here. And that way we get rid of that small amount of duplication. Not onerous, but might as well. All right, let's jump up here and test format, translate simple string. And I mean, if we were doing more than this, we'll do more tests, but because we're simply just testing that our layer works, we don't really need to go any greater detail than what's been provided here. It's not like we're the one who wrote the translation layer. We've got to assume at some point that our library is something we need to depend on. So we're going to do exactly that. All right, so we're going to expect in context.translate, what is it? Standard string. Yep, standard string. Dot to dot equal standard string. All right, does that run? Kick into here. Okay, we've got that. And then translate pluralize string. And this time I'll save the I'll bind the definition. Actually, we might do that up here. So we'll const t. I mean, that is the way we write our usage code anyway, so it's not exactly a large step. And this does make sure that we're binding properly, which is good. So I guess it's smiles all around. Just gonna remove that. Okay, so now we've got some count and some count plural, but both times we call it, we're gonna go some count. We're going to give it a count of 1 and expect it to answer to be there is 1 item. And then next time it's meant to be count 2 or something like that. There is 2 items. And we may as well check 0 as well. There is 0 items. Right, let's run it. Did I just break everything? En context is undefined. Where is that happening? Oh, didn't like that. I'm not sure why. We're in the source. Maybe it's because it's in here that it doesn't like it so much. I'll put it inside each of these and it'll probably behave. We good? Yeah, we good. No worries. All right, yeah, because that wouldn't have actually executed until this before it executed, so it was unsafe. So if we wanted to get around that, what we'd do is something more like this, and then we'd bind it here. inside here. And in fact, we might do, I mean, it's barely saving code at this point, but let's just do it for... Can I even do a type for that particularly nicely? It's not even worth the effort, because I'll just have to figure out the type and all that sort of thing. It's not saving me much code, so let's get rid of that. All right, so now if we refresh, we've got everything all good. We can see all of our matches here. Let's just break one of these tests just to make sure that these tests are actually functional. It's always important to, every once in a while, try and break your tests, because if you just assume that they're all good, it might be that you just didn't write your conditions properly. You should definitely be able to break your tests when you expect them to be. Which is actually a principle underneath mutation testing, which is something we might eventually get into as well. All right. Anyway, that gives us all of our localized context. So we are good and tested there. We don't need to do anything further, at least for now. We've got some basics there. We don't necessarily have 100% coverage or anything like that, because like there are other behaviors. We could, like, what if we throw in valid date times at this and stuff like that? But until we need to have that for testing, there's no point. Let's just leave it. All right, which domain shall we go into next? Because we've only spent 20 minutes, so we've got some more to have a bit of a play around. So we've done localized. We're pretty happy with that. I think we might do persistence, because if we do persistence, then we'll show clearly some things that are meant to work in the browser but will not work in Node. And I think they'll help us make a point. So let's jump into that. So we'll open up database storage. We'll start off with the key value store, because that one's going to be a bit easier than the session key and the persistent key. There's also a lot of code duplication between these two. Yeah, like, but I mean, because both of them are not even longer than 48 lines, I think I'm happy with just leaving it as is. So let's write ourselves a testing for persistence key value storage. So we'll go persistent key value storage .test.ts. And what do we need to do? Nix this, I don't need that in front of me. Okay, we've got a blank page, so let's just grab some stuff from localized context just to get a localize to just get our tests in order. And we'll strip everything we don't need out of it. This is just a function, so we don't actually need to initialize anything. Well, yeah, not really. So I'm just going to nix it all. And finally, we're not doing this. We're testing persistent key value storage. And we don't need a test locale. We do not need Luxon. We just need accept from Chai, and we are good to go. We can rename this to persistent key value storage. And what do we do now? Well, I guess we can yeah, we can just write ourselves some tests, I guess. Set keys accurately. Set simple values. Because the whole idea is we were setting it up so that we could, you remember when we went through this code, we set it up with this JSON stringify as a concept, so that every time we set and get, we get the thing that we expected back, right? Get the thing in pretty much the same JavaScript form as when we put it in. So, for example, if we were going to go set key value item, or rather, I might just shorten that actually. PKVS. That'll go well, won't it? So PKVS dot set, and then what would we do? So yeah, set, get, remove, and clear. So if we set, what are we setting? We let's just set something to the key of test1, and so let's go for all of the primitives and we'll test them. Okay, so we will expect this to be so test1 string, and I guess we could just write an expectation where if we were to get that back, like pkvs dot get test1, we would expect it to equal, I guess we'll do deep equal, even though we don't technically need deep equal for this particular one. We'll use it for the other one. So just for consistency's sake, I'm going to use deep equal for all of them, just to see how it goes. Anyway, we'll do a reload. Okay, so we've got something that works there. By the looks of it, let's just break the test real quick, make sure it goes red. Yep, looking good. Oops. Okay, so let's go through this and just verify that it works for numbers. Because we didn't actually test this. We don't know if we actually got all this. That looks all right. Okay, if we change that. And then I'll do one more where I check if the string is equal. Because remember, JavaScript does weird things. Sometimes this would work. It's not deeply equal. Okay, yep. So the string does not equal the number, which is good. That is what we want. All right, what other things can we think of? Well, let's see if booleans come in and out safely. And we could technically split these into separate tests. And in fact, that's actually not a bad idea. Let's actually do that because if we describe this, set and retrieve primitive values, and then we separate them, then we could do strings, numbers, boolean. All right, and I still haven't fixed that, so it's not going to work. Let's fix that. Very good. All right, and then next off, we're going to set and retrieve deep values. We'll call them object values because even the arrays are actually objects. All right. So let's do just that. We will test against the array. So 1, 2, 3, 4, 5. And actually, just to avoid typing it out twice, I'm going to set it. Because remember, this array, this test array, when we get it back, it won't actually be the same thing. So we'll still have that, like that deep equality test will definitely be valid. And we expect it to come back deeply equal to the test array. Let's give that a crack. It does work. What if we were to say concatenate on a 6? How are we looking now? All right, so you can see a failure there. We cut back 1, 2, 3, 4, 5, and we've got 1, 2, 3, 4, 5, 6. So we broke the test. Good and proper. All right, let's finish off with object. And this one, we'll throw in a bunch of primitives. So Yeah, that'll do. Okay. And we'll change it from test array to test obj. We can actually make it full test object. We don't need to abbreviate it. All right, let's test if it goes green. It goes green. Let's break it. Alright, test breaks because we assigned something else to it. Very good. Okay, this is sufficient for all of that. So now we need to just check clearing and what else we got? Removal. So removal clear gets rid of clear gets rid of everything, whereas removal gets rid of one thing. So remove values. And in fact, we can just make that an it. There'll be one test here, and that's it. So let's remove test 5. And then let's figure out what our test is going to be on the way back out. So where are we here? How are we looking? Expected null to equal true. Okay, so null is our default for things that don't exist. So should be that, which is good. And then what do we got else here? We want to clear, and then we want to make sure that everything is gone after that. So now we should go through all the tests, 2, 3, 4, 5, 1, 2, 3, and 4. And have ourselves an empty test, which we do. Very good. And I might just put that in a describe so it looks in a sensible order, because we do actually need these to run after the other ones. And I think to test this properly, we actually do need to just make sure we do have to check whether it exists beforehand as well. Otherwise, we're not actually making sure that the items were even there in the first place. All right, so we expect all of these things to exist, because otherwise these tests might be moot, because they shouldn't be able to run on their own. They do expect the state of everything else to happen. And this does mean that the tests are not truly isolated. For example, if I was to click on clearance of store here, those tests would fail because nothing sort of got to it, but I'm sort of cool with that just for now. And we could potentially stub that a bit better later. All right, I just got to take a quick break. I'll be right back, and we'll get stuck into the rest of the storage layer, and we'll see how we go for time. So we got another 25 minutes for today. Yeah, we'll just see how far we get, because we might get through some basic testing of the IndexedDB layer as well. Anyway, be 2 minutes. Alrighty, let's go. Now, our tests for our session store key value store are pretty much going to be identical. I'm kind of okay again with copy pasting it, just in case there ever is a divergence in behavior. But for now, I'm just happy to smash on through and essentially write the test the same way. So we're looking at the session key value store .test.ts. Just make it a skvs instead. And then pretty much go through all of it, and we'll change pkvs to skvs. And we are done. So now we have tests for that too. Alright, good stuff. Now what's next? Let's get tests down for our database layer. I mean, this is obviously a little bit more complicated, but we'll see how we go. So if we look at our database storage, we've got some init functions that we need to test. And then once we've got the actual database, then we need to test some of the query behavior as well. So I think we'll just sort of lump it all into database storage.test.ts just to start off with. And if we need to build beyond that, then we'll go from there. But I mean, yeah, there's a decent amount of querying and stuff like that that's going to be happening soon. So I might spend a little bit more time with this. So we'll have one big one, database storage.test.ts, and that'll sort of form our base. And then if we need to explore other stuff, we'll do it in good time. All right, get rid of you, and off we go. All right, so let's get the basics out of the way first. And we've got a test that a database deletion will occur and a database creation will occur. This is, I guess, a little bit tricky because, I mean, we're pretty much going to have to access the database to do it. We have to make sure that the right calls are being made and all that sort of thing. Yeah, it's a little bit weird to write tests for a storage layer, because instantly you're starting to get into this place where it's like, okay, which parts of the system are you testing? But we've got to make sure that when we do a delete DB that we get a promise that resolves to true, and then when we initialize DB and then have it, then we're able to do something with that database. There needs to be something that exists in the system. So how about we do that? We'll start off with a describe of initialization. And we'll just see where that one takes us. Now, in order to do this, we're going to need some sort of test layer. And maybe this is about a good time. So we've got all this test data. Maybe it's time to, pull all of this test data and put it into this, so that when we change our app over to actually use the real data that we wanted to, we've actually got this test database still in place, still using these same concepts, and we can eventually expand it out to cover all of our other things. And it also means I don't have to think of a new test database or anything like that. So if we jump into client, platform, persistence, database storage, and then we'll go yeah, we'll just make a thing called test data. Actually, I know we've already got folders for that. So how about we open this up and we'll take this test data and we've got the state reducer. We don't actually need that. So if we go into part here and we go make a testing data folder. I kind of like, I don't really care that this is bundled in here. Like, it's fine because Webpack won't actually get any of these tests, so it's all good. Like, it doesn't actually affect me at all. So here we go. Let's carry on and grab the things that we need. So what am I looking for? Yeah, test data. So let's grab that. We'll copy that over because we still want to keep our app running for now. We'll put this into testing data. And then what we'll need to do is also make one for the scaffolding. So for the schema and that kind of thing. So if we go to client, platform, database, persistence, database, testing data, and then we can chuck in the schema and migrations in here. So make a schema file. Oops, gotta save that one, and then we'll make ourselves a schema file. We've got ourselves some bits and pieces there. We'll just essentially fix all the errors. We will export the schema as the default. So just going to do that quickly. But otherwise we need to grab together our migrations, which you can see just here. And then we need to grab database storage to grab all of these bits and pieces. And we can do that by bringing this out of database storage, but then also we need to import the actual library. So we'll grab database, or not library, but rather module. And I think it's index. And we've got everything we need, so we've got ourselves a schema. Good stuff. All right. So now that that's working like that, and we've got our test data sitting in, we've got all articles and all authors that we should be able to require in, we should be able to run some tests like this. So if we jump into daisy, if we run into database storage .test.ts, okay, so we need to pull the schema from testing data schema. Let me just see what authors.ts looks like. So yeah, default is the authors. Okay, so we've got all authors, and that comes from authors. We've got all articles, and that comes from articles. Not that we're going to be using that straight away. We're just going to do some basic tests here. All right. So the interesting thing about these tests is now we have to go into the world of asynchronous tests, and we may as well take a quick look at the Mocha documentation before we Mocha test. This is the thing, because I'm using a profile browser that's I've never used, like this is a clean profile that I've been keeping for Weekends Web App for both Firefox and Chrome. It means that I'm not in any search bubble, so it's not trying to, put me to places where it thinks I need to go. Otherwise, it probably would have put me straight into that, this testing library. Anyway, simple async. So we've got this done function, and we can use that to handle it. But we can probably do promises as well. So if we return a promise, then we can probably do what we need to with it. Yeah, so if I return a promise, then it should be fine. And then we can use chai as promised for fluid promise assertions. That's interesting. That might be useful, but we'll see where we end up with that one. Returning a promise and calling done will result in a mistake. Okay. Cool. But if the promise rejects, then I would assume that a rejected promise ends up being a failure. And I guess we'll see how we go with that in exploring it further. All right, anyway, let's test this code. We've got database storage. Let's focus in on that so that we're only running those tests. And then have at it, I guess. I might just have to remind myself of the usage code just so that we're not sitting here making very little progress. So here we got this delete DB. We're going to have to test deletion of a DB after we initialize a DB. We can see here that the schema has the name of the database there, so we're going to have to update that. So if I jump to the testing data schema, I'm obviously not going to want this to be WWA data because that would affect the app state. So we're going to go test database. That's what we'll call it. All right, let's have a crack, eh? So we are looking for our database storage, import database storage, and we're going to import that from the index space, the index folder here. So we're going to start off with returning database storage, dot create database, I guess. Initialize DB, that's the one. And that returns a promise, right? So what we're really looking to do is probably more like, okay, so we've got a DB that comes out of that. And then we can return DB dot then. Oh, it's thenable. So actually, it might be fine to return DB. Let's see how that goes, hey? So we'll initialize DB with schema, see if it crashes and burns or not. Okay, so that seems like it worked. Didn't call any errors, and I guess we can have a quick look in the console. And it looks like we got a database success there, so that seems successful to me. And let's see if we can remove a database. So database delete DB. Test database. So now here's where it gets weird. Well, not exactly weird, but like we have to test that assumption somehow, don't we? So we've probably got to do something from here to actually get ourselves in a place where you can test that assumption, right? So after that happens, we've got to do something that sort of asserts that that worked, and this is pretty much going to require us having to go check whether we've got that database, right? There's no real way around that. So I'm going to have to essentially write some code from here, uses the same concept and just verifies whether it fails when we try to open that database. That's probably the big thing right there, is if it succeeds, then that's the problem, right? So let's, if we get into here and then we return a new promise, and we can either resolve or reject. And this is sort of going to be a reverse promise, because we're going to resolve on failure and we're going to reject on success. Because what we want to do is check if test database does not exist. And we'll give it a version number of, well, anyone really. We'll just give it free. It really is immaterial. Okay, so we've got a request here. And we've got on success or on error. We don't need to actually do any on upgrade needed. We can sort of just ignore that side of things. And we just flip these over. And we'll see how that goes, whether we've actually got ourselves a test. No. Can remove database, timeout. Async text and hooks. If returning a promise. That's interesting. Maybe I need to open this up just a wee bit. I'll run a console log in here and see if it actually gets here. Oh, of course. Okay, so like the database is created by opening it. I'm a moron. So whether we can actually test for the existence without actually opening it, let's just have a quick look and see if we can find some sort of way to do that. Where's the API for where IndexedDB? I might have to just jump into the console layout and see what we can find. IndexedDB dot. We have open and we have delete. Okay, well, if that's the case, then what we need to do is actually check. We do actually need on upgrade needed, because what we need to assume is that version is going to be 0 if the database did not exist. So we'll go on upgrade needed, and we'll do on upgrade needed, and that's let's console log on the event and see if we can figure out where we're at here. Did it even get there? That is a question. Because it kind of is looking to me like it didn't actually get there at all. And it should actually be coming back as a promise. So let's check that out. Yeah, we never even get the can remove database as a thing. Maybe I'll just have to put something around this to get it behave itself. Normally it doesn't do stuff like that, so I'm not really sure what's going on here. So we've got this delete DB function, and it doesn't look like it ever even called it, because I'm not seeing it here. Not seeing it at all. Is it maybe because this DB never gets removed? This is intriguing me. All right. But I mean, this is a good showing of like where, you know, isolating and testing and all that sort of thing starts to get a little harder, right? Because we've got can remove database running, and we've got here can init database. All right, and this is probably a problem. I reckon what's happening is this is open. Yeah, so these both running side by side, and that is because this is not basing itself off the DB promise. So the database promise rather. And is it Zenable? It's not Zenable. I thought it was Zenable. Guess not. Okay. What about on initialized DB? What am I looking for here? Database storage index.ts. So here, yeah, we return the new DB. Okay, so we do not have the promise in any sort of reasonable way here. So that's sort of not enough. And we can't just go through and run all our saves. We got to sort of add some sort of then behavior to it, or just return the promise. For the moment, I'm going to keep it cheap and cheerful and just get the promise out, although technically that's meant to be something internal. You're not supposed to touch it, but I'm going to break the rules just this once. Actually, what I might be able to do, because this is test code, I'm totally fine with coercing this and just saying, hey, I'm allowed to do anything I want. Let's see how that goes. So yeah, we've got some timing here, and we've got can remove database running after, which is potentially getting closer to where we need to be. But it never runs, and that we need to figure out. So, I mean, this is worthwhile testing. This this whole concept of like when does it allow us to do what we needed to do. And you can see that nice little timestamp there that lets us know how long that function actually took. we've got it set on pending, and I guess it might have something to do with this DB object, which is holding the index database open. So what we sort of need to do, we need to close it. We need to close it readily. And we do have a close connection function. If I check back here. So we need to close that connection in order for it to be successful. And it looks like that comes off the promise. So maybe we could do that. We could return db.closeConnection. Because that is a promise. It returns a promise. So maybe that's enough. So we've got can init to database, can remove database running. Yeah. The event is trusted true was throw an error. Yeah, that's interesting. This is worthwhile testing anyway, because it gives us a sort of an experience of how bulletproof our thing is. This testing does sort of help address this, but it looks like it comes up to an error almost straight away. Close connection issued. And it doesn't even try and start the database anymore. That is unfortunate because we don't want it to try and do that until that DB promise resolves, and it shouldn't resolve until the database is finished creating. So it looks like some weird things are happening in Dodge here. Because that DB promise, that one right there, should not be ready until everything else is ready. And it doesn't look like that's really happening right now. So if I get rid of that, we've got some errors happening there. I believe if I just put an X in front of this, it won't run that test. And now if I run it, we've still got database errors up the wazoo. What are these? Maybe if I keep that turned off, we can see where we're going. Okay, so we just got a straight up error. We need to figure out what that error is precisely. Maybe if I get a bit of better logging on it. Database error. We've got an error. Let's see if we can get something better information here. Alright, well, that doesn't give me much. It's an event. It is an event after all, so I guess I'm going to have to go digging to find the information I want here. I guess this is where it gets interesting, and we're almost burnt our time. But that's fine, because, I mean, we do have to figure out ways to test this sort of stuff. I just need to identify what precisely this error is, though. Fortunately, it's not giving me much right now. Ah, here we go. Because the stored database is actually a higher version than the version requested. Ah, so that is an issue, right? Because we've got this open happening. And then we would need to delete afterwards. So after all of that, So after all, we need to return database storage .delete DB. Otherwise, we're always going to end up in a downgrading situation, and we don't want that. Okay. So now we're good, and we've got a tick. We've got things working as we expect them to. Okay. So now we're in a position potentially where we can get that promise working there, and then we can run through that can remove database function. So the after all hook did its thing. Okay, yeah, the after all succeeded, which seems like it's all good. So now we can potentially run this test as well. Okay, we've got an error there, and that's fine. We will figure out what's going on there. So database deletion was successful. But we've now got to figure out how to reverse all this. So we're not resolving here, and we're not resolving here. We're really all about testing right here on upgrade needed. Yeah, so we've got new version and old version. You can see that right here. So we need if old version, so if ev.old version equals 0, then we can resolve true. Else we're going to reject database with version, and we'll output that number. ev.new version, old version already exists. That is, I think, most of the tests, so we can get rid of this on error and on success, because this is really what we care about. Now, we did not let go of the request here. Maybe that's an issue, because we've got our timeout there. Maybe not. We've got a database deletion that's successful, but I'm not sure whether the hook returned as it needed to. Ensure it resolves, yeah. So we're not getting a resolving promise here. So we can get this is working, but then we don't get a resolving promise on the after hook. So we might have to make sure that we're letting go of this connection, and we don't actually resolve and reject until request on success. So what we do to get away with that is, I suppose, we do result. Yeah, we'll let result, and it could be a string or it could be Boolean. So here the result equals true. Here the result equals this string. And it's only at this point that we resolve. So if result equals true, then we'll resolve here. Otherwise we reject the result and we're good to go. So I think this will give us some testing. Like this will work for us, but we'll see how we go. Doesn't look like it. Okay. Let me just see how these race conditions are playing. Luckily, once we get past this sort of init stopping sort of scenario, we should be a little bit better. All right, the after hook is kicking in here. So that should not kick in before the after the afterhook, which it seems to. It seems to be playing the game here. But this deletion of database is happening too slow. So we might have to raise the timeout for it. Yeah, I have this feeling we're going to have to raise the timeout to that afterhook. So we'll have to look into how Mocha does that for us to get some get that working. What do we got here? Asynchronous hooks. How do I change the timeout? Timeouts. All right, good. Sweet level. Okay, so maybe I can use this dot timeout. So if I do function and then do this dot timeout, we'll make it 5,000 milliseconds, and we'll just see whether that does it for us. Because I mean, it might be that it's just blocked. It looks like that. So I don't think it doesn't matter. It doesn't matter what we set this timeout to. It's just broken. But maybe all we need to do this is maybe we just need a delayed promise. Maybe that would be enough. So if we were to do something like, say, yeah, maybe we could do this. So do this dot set timeout. We do things inside of it, and then we just give it a slight delay, just so that it's not sort of kicking in too early. So we got resolve, reject. I don't believe I have promise delay available to me, otherwise I'd do that. That's more of a Bluebird thing. That's sort of like, it's a library that gives you a lot more to your promises. You can't just do delay. You have to do your timeouts on your own. So we'll resolve true inside here, and then we'll do the database storage deletion, delete DB. So if we throw this delay in here, maybe things will pay attention to us. This dot set timeout. Oops. That should be window dot set timeout. Alright, well this one's interesting then. I don't know what the actual problem is. Like, I want to delete this database, and it seems to me like it's working, but it never actually gets to the resolution. And we even have ourselves a database deletion successful. We've got the first database deletion, but we don't actually get the second one. It's pending, and it's pending for some reason, and it possibly has something to do with this. And I wonder whether if we could get away with some sort of timeout on that, we could do the trick. Or maybe what we're really after here is just an extra then here, just to make sure that we're completely, well and truly out of the woods. So we'll just return true here. If it rejects, it rejects. If it resolves, it resolves. Yeah, still doesn't do it. Not a fan, not a fan. I would really like to get rid of that test database and just have it succeed. I mean, potentially... Yeah, I'm not even going to be a fan of, like, not sort of cleaning up after myself, just because if we have more tests that run after this, some of them might expect that this test database is well and truly deleted by the end of it. So the idea of it sitting on pending is kind of not alright to me, and I need to figure out how to get around this. And it never even happens. You can see it takes forever. Okay, it did actually happen. You can I just saw that there, and that took a little bit longer, but it did actually happen. But it took ages to get there. So maybe we do that. We just give it a this time out. 10,000. We'll give it 20,000, which is 20 seconds. If that's literally all it takes to get this past this deletion test, then maybe that's enough. Promise resolved. Why didn't it acknowledge it? Alright. Well, if this is the case, then I might have to just use the done handler. So we'll go then done. Maybe this will play the game for us. Oh no, it doesn't even tell me if it works. So it did actually work. We just didn't have any extra tests to run. And what we can do is we can test this by, I guess, pulling out of here and actually testing everything. It's taken a while to let it go. Exceeded the hook of 20,000 milliseconds. Let's see if that database deletion comes up here. Never comes. All right, let's try it again. Alright, maybe I do need to do it this way. Let's just try that. But I mean, I'm not actually seeing the deletion confirmation here, so doesn't seem like things are behaving the way I'm expecting them to right now. Done invoked with non-error. True. Okay. Well, if that's the case, that did actually make it through the gate, so let's give that one a try. I feel like this one's going to end up in the realm of flaky tests, which is unfortunate, but I mean, it's not always avoidable. This isn't really a flaky test, but more a flaky teardown, where it has to do something after the test actually takes place. Taking a long time. What about this time? And part of this might be, this is just going to be nasty, and maybe like that one worked. Took a while to get through it, but it worked. But maybe what we're better off doing is not even checking. We'll just make sure that the behavior works, as in it does it without collapsing in a heap. And potentially we'll do some more exercising down the track. Because it looks like that process of opening and then closing is just proving more of a more problematic. Of course. Yeah, I don't have a closed connection object here, but maybe that's all I need to do. I need to find that IDB item and just close the DB. So inside here, this resolution of onSuccess, I need to make sure that I close it. So ev.db.close. Maybe that's sufficient. Of course, I'm just overlooking things that are in the API and ending up into trouble. Here we've got ev.target.result. So we're looking for ev.target.result, and then we close the database right here. And maybe this is enough, and now we can get rid of this timeout. Return that. We'll get rid of this function. Done. And we'll see if this brings us back into where we want to be. We good. All right. Finally found the issue. Okay. So we need to make sure that we close the connection, we resolve cleanly, and then we're good to go. So I guess it's worth just explaining what the problem was precisely there. So when I open this, without running closed connection, what happens is IndexedDB just sort of keeps any subsequent operations pending. It holds onto them for some amount of time. And you know, sometimes it gets to hint and just closes it automatically. But if you want something to explicitly close that database connection so that you can start to do things like delete the database, you have to be explicit. And we solved that up here with our closed connection. And then I should have connected the dots and realized I've got to do it here as well. I've got to do this target.result.close, result being the IDB database instance, which we use over here. Anyway, now that we've done that, we've got, I guess, some level of testing. And you can see here, if we look through all of our code, we've got everything testing in Harmony. It's setting up, it's tearing down cleanly. We've got the persistent key value storage. We've got a duplication of a name there, so let's fix that. And we could do some we could reduce down these tests by reusing some values and stuff like that, but I don't need to do that right now. Okay, so that gives us some basics for database storage. We need to do a lot more with our database lab because we're going to be leaning on it a lot more. But at least this gets us a bit further for our testing layer. I would hope that we'd get, now that we've sort of overcome that little hurdle that we're in, we can probably make a bit more progress with getting the rest of these tests down so that we can get into the next phase of actual development. All right. Not that this isn't development, but I mean, it's not exactly like we're making new things right now. Okay, so day 19, testing, improve testing of persistent data. Hang on, we add tests to rest of localized context plus persistent storage. That'll do. Sweet. Okay. Oh wait, I missed a few things. Let's make sure we put them in the commit. Okay, I'm also going to make sure I didn't miss anything. I did not. Okay, and today is day 19. Push that up and push up the tags. As per usual, if you want to catch up with the code yourself, you can find it at github.com/weareoffcider/weekendswebapp. That about does it for me. It's late, I'm tired, and I will try and do another stream tomorrow night after I get the little ones to bed. So that'll probably be more like 9:30 p.m. I won't put a time down. I'll just stream when I find the time for it. But yeah, I want to keep on burning through this stuff so that we can get back into our progress in the thick of things. That's it from me tonight. Thank you very much for watching, and I'll see you next time.